Good morning. We're going to continue on with our study of conic sections and look at 11.2 parabolas. Okay, we've done parabolas. You did parabolas in Algebra 1, Algebra 2. We've talked about them in pre-calc here. This form is a little different than what you've seen before. Just to review, parabola, not really to review, but to talk about this in different terms. Parabola is a set of all points that are the same distance from a fixed point called the focus and a fixed line called the directrix. Neither one of them are actually on the parabola, but it's the same distance. So if you look at this diagram here, they have like a point highlighted or a point kind of marked out here. So this point on the parabola is the same distance here to the focus as it is from here to the directrix. Same thing with this point here. This point on the right side is the same distance from the focus as it is from the directrix. That's how they come up with the parabola. There's a simple way to sketch the parabola in this form. You're going to plot your vertex in the focus. You're going to draw the directrix and then draw a line through the focus that's parallel to the directrix. It's called the lattice recta, and its length is 4p. You'll see where that comes from in a second. And its endpoints lie on the parabola. So once you draw that line in, your parabola is going to go through those endpoints of that line. The standard form of a parabola, you can either have x squared or y squared. If you have x squared, it's going to open up or down, depending on if your p is positive or negative. And y squared is going to open right or left, which we haven't seen before, depending on if p is positive or negative. And those are both if your vertex is at 0, 0. But if your vertex has been shifted at all, and it's at hk, it's going to look like this. So same idea though, if it's x squared, it opens up or down. If it's y squared, it opens left or right. Okay, so we're gonna go ahead and practice graphing these and writing the equations. So first example is actually example 8 in your packet. We're going to sketch and find the equation of the parabola with the given vertex and focus, and then sketch it to find the equation of the directrix as well. So I actually think it's easier to start with your focus and your vertex. So if I plot those two, the distance between those 2 points is 2. So that means my p is 2. The equation for your parabola opens up, and I know it opens up because the focus was above my vertex, is going to be x squared equals 4py. So we're going to plug that 2 in. So x squared equals 8y. Okay, pretty easy there, right? So since my p is 2, that means I'm also going to go down 2. Here's my directrix. And if my p is 2, that means this here is going to be of length 2. Sorry, 4p would be 4 times 2, which is 8. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, so my parabola is going to go through that endpoint and that endpoint. Okay. Let's try another one. Okay, vertex is 0, 0. My focus this time is negative 2, 0. So my p is negative 2. And since it opens to the left, I know I need to have y squared equals 4 times negative 2 times x. So y squared equals negative 8x. Since my p was 2, absolute value of my p was 2, this is my directrix here. That's y equals negative 2. This is x equals 2. Okay, and then my length here is going to be 8. So 1, 2, 3, 4. 1, 2, 3, 4. And it's going to open like that. Wow, that was a really bad parabola. Let's try that again. Okay, last one. Vertex is at 0, 0. Focus is at negative 1/4, which is really hard for me to show you on this. Use a different color here. So negative 1/4 here. So the distance is negative 1/4, or P is negative 1/4, I should say. So I'm going to go ahead and draw my directrix in up here. And I'm going to do, since it's opening down, I'm going to do x squared equals 4 times P, which is negative 1/4, times y. So x squared equals negative y. Okay, so since this is 1, negative 1, my length of my lattice rectum total should be 1. So that means our parabola here is going to be really tall and thin. Okay, this one, if you change this around, you're going to notice that that's something we graphed last semester, so you could also look at it that way. Okay, what happens when our vertex is not at the origin? So if I have the point 2, 3 over 2 up 3 for my vertex, and I have 2, 2 for my focus, P is going to be negative 1 because my focus was below my vertex, and it's opening down, so I have x squared equals 4 times P times y. So my equation is x squared equals negative 4y. So my directrix here is above, so that's y equals 4. And my length of my lattice rectum is 4, so I need 2 on each side. So these are points on the parabola. For the next one, our vertex is at negative 1, 2. The focus is at 1, 2, so over 1 up 2. The focus is to the right, so it's going to open to the right, which means it's y squared equals 4 times P times x. So y squared equals 8x. I'm going to go ahead and draw my directrix in here. So this is going to be 1, 2, 3, so x equals negative 3. Okay. And then the length of our lattice rectum is actually going to be 8, so we need to go 4 to the top and 4 to the bottom. And I'm going to apologize because you can probably hear my son throwing a fit in the background. Homeschooling is hard. Okay, last one we're going to do here. Plot this, negative 3, negative 2, and negative 3, negative 0.5. Okay, this one opens up. My P is going to be 1.5 or 3/2, depends on which one you want to use. And so if I go ahead and plug this in, since it opens up, I have x squared equals 4 times P times y. And 4 times 1.5 is 6y. I'll go ahead and do 1.5 here. So here's my directrix. Okay, my lattice rectum is going to be 6, so I'm going to go 1, 2, 3 to the right, and 1, 2, 3 to the left, and my parabola goes through those 2 points. Apologize for the sloppy parabola, and you should be good. Okay, next one. Find the equation with given information. The distance from my vertex to my directrix, because it's my y, is going to be 3 minus 6. So my directrix is going to help me have my P. So my directrix is negative 3, which means my P, my P is negative 3 because my directrix is 3 above. So my vertex is going to, my focus is going to be 3 below. When I plug this in, since it's above and below, I know it's going to be x squared, but my vertex is 2, so x minus negative 2 squared equals 4 times P times y minus 3, and then we can simplify. So x plus 2 quantity squared equals negative 12 times y minus 3. And we can leave it like that, or you could distribute and square this out and put it all in general form, but we'll leave it there. Okay, next one, focus and the directrix. So if my focus is at x equals 2, and my directrix is at x equals negative 2, my vertex is going to be halfway between those two, which would be at 0. -1. Okay, and my P is 2. So when I plug this in, I'm going to do, and then this is x equals for my directrix. So this is going to open sideways. So I'm going to do y plus 1, because my vertex squared equals 4 times P times x minus 0. So I get y plus 1 squared equals 8x. Okay, for this last one, it tells me my vertex is at 0, 0, and that it opens up. So since it opens up, I know that I need to use x squared equals 4py. And then I'm going to actually plug in x and y here to find my p when I go ahead and do this. So x squared, so 2 squared equals 4p times 16. So 4 equals 4p times 16. I can go ahead and divide here. So I actually get 1/16 equals p, because 4 times 16 is 64 there. So now all I really have to do is plug this in. I have x squared equals 4 times p, which is 1/16, times y. So I have 1/4 y. Okay, last one. This is where you complete a square. Find the vertex, focus, and directrix of the parabola. All you really need to do is put this into your standard form there. So I'm going to move my 12y to the other side. And if I rewrite this with my 4 out front, it's really 4 times -3y. So my vertex is at 0, 0. My focus is going to be, since it opens, this actually opens down, it's going to be 0, -3, and my directrix is going to be y equals 3. Okay, for the next one, going to do kind of the same thing, except I'm going to move everything over. So I have x squared equals 4y plus 4. I'm going to factor out the 4, so I get y plus 1. And then I'm going to divide by 4, so I have my p there. So 4 times 1 times y plus 1. My vertex is 0, -1. There's nothing with my x, plus 1 with my y. My p is 1, so that means my focus is going to be 1 above, because it's x squared, and it's positive, so I'm going to do -1 plus 1, which is 0. And my directrix is going to be my vertex minus 1, so y equals -2. If it helps, you could graph that and see where you're at. Last one, I'm going to go ahead and complete the square here. So y squared minus 2y plus something, and I'm going to move the other stuff to the other side. So minus 8x minus 9 plus that same thing. Half of -2 is -1. -1 squared is 1. So I'm going to add 1 to both sides. And then I'm going to factor. So y minus 1, quantity squared, gives me -8x minus 8. So I'm going to factor that and divide by 4. So I get x plus 1 when I factor, and then if I divide by 4, my p is -2. So my vertex, my x has a plus 1, so it's -1. Change our sign. My y has a -1, so change the sign, it's a +1. Because it's y squared, this opens up or down. Or sorry, left or right. My p tells me it's opening to the left, so keep that in mind. So my focus is going to open to the left, which means my x is going to change. So I have a -3, 1 for my focus, and then I'm going to add 2 for my directrix to get -1 plus 2, which is 1. Okay, so if it helps, vertex, focus, directrix, just so you can kind of keep an eye. This is -2, this is going to be +2. That's all you're really doing here. Let us know if you have any questions. Have a great day.